This podcast is on the subject of even and odd functions. I'd first like to demonstrate what I mean graphically by an even and an odd function. How do we determine by looking at a graph whether a function is odd or even? Well, a function is called even if it has symmetry, that is line symmetry, in the y-axis. Let's take a look at the first example problem. Looks kind of like a W. Finish it off there. If I imagine that to be on a piece of paper and I imagine folding the paper on the y-axis, then the right half of the W would drop over and be a perfect match for the left half of the W. This point would lay on this point would lay on this point, etc. Be a perfect matchup. That's what we mean by line symmetry. And since this line symmetry is in the y-axis, this is even. Take a look at the second one. The second one also has line symmetry. If I fold on the x-axis, this point would come down and lay on this point, etc. This point would lay on this point. It's a perfect match. However, to be even, the line symmetry has to be in the y-axis, not the x-axis. So this is not an even function. Let's take a look at the third example. This function also has good line symmetry. But the line symmetry again is not in the y-axis, it's in this line, and this is the line x equals -1. Now, the only way it can be called even is if it has its line symmetry in the y-axis. And clearly, if I fold it on the y-axis, this point would not lay on this point. So this is a no, this is not an even function. And of course the last one is an even function. If I fold it on the y-axis, this part would lay perfectly on that part. So that is even. Let's take a look at what we mean by odd functions. A function is called odd if it has point symmetry. Now, point symmetry is 180-degree rotational symmetry. If it has point symmetry in the origin, let's take a look at the first example. Imagine that this picture of these two golf club looking things was on a piece of clear acetate, and this center point, the origin, was a knob attached to the acetate, and I turn the knob a half of a turn. Then the upside down golf club here would come over and lay perfectly on the right side up golf club. And the right side up golf club down here would turn over, it'd become upside down and lay perfectly on that one. So the final result would be, after I rotated 180 degrees, the figure would be exactly the same as it started. So this is an odd function. It is got point symmetry in the origin under 180-degree rotation. Take a look at the second one. If I put my knob here and I rotated this picture 180 degrees, that's half of a turn. The two golf clubs would be upside down on the bottom, so it wouldn't be the same picture you started with at all. So these are not odd functions. Take a look at the third picture. This is kind of a famous curve from trigonometry called the sine curve. And it is an odd function because if I take the hump on the right and I turn it a half of a turn, it will become the cup on the left. And if I take the cup on the left and I turn it half of a turn, it will become the hump on the right. So the figure I end up with will be exactly the same figure that I started with under 180-degree rotation. So this is an odd function. Now the last figure is exactly the same figure as the third figure, but it's been moved a little bit. It does have point symmetry, but the point about which it's symmetric is this point. Now I want to emphasize that in order to be an odd function, the point symmetry has to be in the origin, not in some other point. So this is not an odd function. Well, why do we care whether a function is even or odd? Well, if you could find out in advance whether a function is odd or even, then you only need half of a table of values to graph it. For example, suppose that we had made a table of values and we had graphed this half of our first example problem, but somehow or other, and I'm not saying how, but somehow or other, we knew that it was an even function. Then we would know that if we folded right here on this line, we'd get a perfect mirror image of the other side. So great help when you go to graph functions by cutting your work in half. Well, can you just by algebra, without seeing a graph, determine whether a function is odd or even? So I've written it down here. Here's a rule for determining odd and even by algebra. To determine algebraically whether a function is even or odd, compute f of negative x. That negative isn't very clear there, so I'll stick in a big one. Compute f of negative x. If f of negative x is exactly what you started with, if f of negative x is the same as f of x, it's even. If f of negative x is the opposite of what you started with, it's odd. You can see that up here in this example. Suppose I go out here to x, and I look up to see what y, or f of x, corresponds to that. So I read over to this y, which is f of x. Now suppose I go over here to this point, which is negative x, and I look at its y. Well, it's got the same y the other one had, but this point is not called f of x, it is f of negative x. So I've just shown f of negative x is the same as f of x. So that's where the first rule comes from, and the second rule is similarly derived. So let's take a look at the first problem. It says, is f of x equals negative 2x squared minus x to the fourth even, odd, or neither? Well, according to the rule, to determine this, we have to compute f of negative x. So I'll start off by writing f with empty holes. Then I'll put negative x into each empty hole, and then I'll evaluate. Well, the negative 2 doesn't change. When you square a negative, you get a positive, so that's just going to be x squared. This minus doesn't change. When you raise a negative to the fourth power, you still get a positive, so this is going to be x to the fourth. Well, that's exactly what I started with. That is exactly f of x, so I just showed that f of negative x is the same exactly as f of x, so this is even. Now let's take a look at our next function. It says, is f of x equals 6 minus x cubed even, odd, or neither? And again, whether you're checking for even or checking for odd, you start off by computing f of negative x. So I'm going to write f with empty holes, empty hole cubed. I'm going to put negative x in the empty hole and proceed. Well, I'm not doing anything to the 6, so it stays a 6. The minus sign doesn't change, and now I have to cube negative x, and when you cube a negative, you get a negative, so I get negative x cubed. So I get 6 minus a negative. Well, minus a negative is plus a positive, so I get 6 plus x cubed. Well, that's not exactly what I started with. I started with 6 minus x cubed, so this is not even. And in order for it to be odd, I have to change every sign of every term. I did change the sign of the second term. The second term was negative, now it's positive. But the sign of the first term changed the same, so this is neither odd nor even, and that concludes the podcast.